Hi guys, this week we are going to be talking all about volume. Last week we talked about area in extensive detail. We're going to change that now to our three-dimensional objects. So one of the first questions I usually talk about is what is the difference between area and volume? Okay, you guys just got to think about that. There's three things that we look at in terms of when we find values in our real life structures. First is perimeter. You guys know that as the distance around a shape. So if I have, for example, if I have this square, the perimeter would be the distance all around. If I were to walk around the shape, that would be perimeter. Area is how much space is inside of that shape. Now, both perimeter and area talk about two-dimensional features of that shape. Volume takes that square and makes it into a cube. And instead talks about how much can fit inside of this giant cube. Okay? So it takes that idea of area and just raises it to, instead of what can fit inside this one level, what can fit inside this entire figure. So in order for us to talk about our volumes, we're going to first have to talk about what are the different shapes that we're going to be seeing with three-dimensional, because things like squares, triangles, circles, we talked about all year. We're familiar with that. Some of these you guys probably have heard, you guys are probably familiar with, but maybe need some connection in terms of when you see that word, what does it truly mean? Starting off with prism. A prism is a 3D figure with two congruent bases and lateral faces that connect them. So in this picture here, you see that I have a prism that has like almost like a quadrilateral trapezoid base, and then it has faces that connect them. Now this prism can look like a bunch of different things. A lot of people just think that it's going to be a rectangular prism, which would be your box, okay? But you can also have something like a pentagon prism, where you have a pentagon base connected wrong sides there, connected by lateral bases. Okay? Keep in mind that with our prism, the top of the prism and the bottom of the prism are always the exact same size, and then the sides that connect them do so at the same height. So the height of every single one of these lines are the same. Okay, that's what makes that a prism. Next, we're going to talk about a different kind of prism, which is a cylinder. Now, a cylinder is just like a prism in that it has two congruent bases connected by a lateral face, but instead of those bases being our multi-sided shapes, such as pentagons, hexagons, and so on, we have a circle as our bases, and we have one single face that connects them, one round face there. So just keep in mind that we still have our congruent bottom base and our congruent top base, and we have a height that is the same all the way around this cylinder, but the only difference between this and this is that this has circular, this has non-circular, and that this has only one lateral face and this has many. Okay, taking that same idea, let's talk about a different type of 3D image, which is a pyramid. Now, a pyramid is kind of like a prism in that it has a base that can be a square or a rectangle or a pentagon. However, those lateral faces now come to a central point, such as this one here. Now, the circular version of that would be your cone, where you have your circle base and then the lateral face all meets at that common point in the middle. Now, again, the ones you guys probably think of when you think of pyramid and cone are these images, but for that pyramid, just again keep in mind that you can have a weird base that all comes to a cone, okay? Sorry, not a cone, to a central point, making it a pyramid. So keep in mind that difference, that it's not always going to be that rectangle or that square base on a pyramid, such as the Egyptian pyramids that we see, but it could change depending on the base. Last but not least, our last 3D image we're going to talk about is a sphere. A sphere is going to be that ball-like object. It's round, 3D, and all the points on the surface are equidistant from the center. So what that means is that if I were to put my finger on any point on the sphere, it would be equidistant to the very center of that sphere. The same thing as that any person, you know, if we were thinking about around the world, that the sea level is all equidistant to the center of the earth. And that's because our radius here is the same distance to here, to here, to here, to here, to here, wherever. It's essentially your 3D model of a circle. So using those are just going to be our vocab in terms of what do they mean when they say a prism, what do they mean when they say a cone, what do they mean in these words. Let's actually talk about the formulas for these shapes though. And you notice we talked about 5 shapes, but you only have 3 formulas, and that's because some of these formulas stack on top of each other. So let's go ahead and start with volumes of prisms and cylinders. So as I said before, prisms and cylinders are essentially your base, your area of your base, and then you have this common height that's happening, and that height is the same way all the way around. So essentially you're stacking these circles or stacking these rectangles or whatever over and over again. So the area of our base is going to be purely simplified to our area of our base, okay, and you can put sub B if you want to remember, area of our base times the height. Okay, so essentially you have base times height again, which is weird because base times height was a huge formula from our area from last week. That's essentially what's happening. If our area of the bottom is 10 and our height is 3, then essentially we're taking that bottom piece and stacking it 3 times. So that would give us 10 times 3, area of the base times area of the height, as our total volume. And same thing for a cylinder, because a cylinder takes the same concept but just changes what type of base you have. So it would be your area of the base times your height. And that's also written right here for you guys. Moving on to our next volume formula, which is going to be volumes of pyramids and cones. Again, I'm grouping these together because they're essentially the same type of shape. You have a base and you have them all coming to a central point, which means that the base is the only thing changing. So what we're going to have here is we're going to again use that area of the base, but instead of just doing base times height, we're going to do 1/3 area times height. And again, that's area of your base. So one relationship that we have seen between cylinders, prisms, and our cones and pyramids is that a cone is exactly 1/3 of a cylinder if it has the same type base and the same height. If I filled this up with ice cream and I put it in this bowl, it would take 3 complete trips there to fill that bowl completely up. And same thing for your pyramid. If these and these have the same height, same base, and I filled this up with something and poured it in here, it would be exactly 3 to fill that up. So there's this relationship of 1/3, that when it comes to a central point, it's now 1/3 of the area that it would have been if it was just congruent base on top, congruent base on bottom. That leads me to our last formula, which is for a sphere, which is going to be 4/3 pi r cubed. Now this is the only formula I'm giving you guys today that's very specific in terms of I have a value, I plug it in, I'm done. Because the volume of spheres is technically 2/3 of a circumscribed cylinder, okay, which is a lot to kind of grasp. If you're curious about, like, hey, what does that mean? What is a circumscribed cylinder? How does that formula come to be? Let me know, and we can talk about it one-on-one on video chat. But I'm just going to go ahead and just give you guys the formula here and not have to worry about explaining that. So we have three formulas to talk about. We got area times height, we got 1/3 area times height, and then we have 4/3 pi r squared, cubed for our spheres. Now for all of these, I want you guys to keep in mind that volume is going to be measured in cubic units. Okay, so when we answer our questions today, if we have units to give, let's go ahead and answer those correctly. Let's go ahead and do our examples. We got 5 problems to talk about using these different formulas, and we're going to start off with our prisms. Okay, question 1, what is the volume of each prism? Now, the volume of each of these shapes is again going to be the area of the base, the area of the base times the height of the object. So you really just have to figure out what is my base, what is my height. Okay? You guys might be familiar with some other formulas, and when we're doing this, you might be thinking like, wait, for example, this one, I thought it was just base or length times width times height. And you guys are 100% correct there if that's what you were thinking. Length times width times height is a formula for a rectangular prism. And the reason why that happens is because length times width is your volume, your area of your base. So if I take a look at this shape, if I say that this is my base, okay, then my area of my base would be 24 times 20, or your length times your width. But then I would take that and then multiply it by my height, which is 10. And that's where that length times width times height comes from. I'm just giving you guys a more generic equation that can be used in any prism, not just rectangular. Regardless, 24 times 20 times 10 is going to be my answer, which is 4,800 centimeters cubed. Okay, now that's a pretty easy one. Rectangular prisms and cubes are going to be your easiest ones to do. But let's move on to these other ones, which you guys see we have triangle bases. Now again, you got to recognize what is my base and what is my height here, because that can be the thing that screws us up the most. So you want to look at the shape and say, okay, where's the top of the shape and where's the bottom? Where is the two bases that are the exact same? And that would be here. Okay, so you have this triangle base on B. Okay, I know this is my base because if I look at the other side, I have the same triangle. If you were thinking that this rectangle is your base, okay, look opposite of it. There's no congruent rectangle across from it. So even though it's kind of tilted on its side, you got to make sure you recognize what is my base. So because I have a triangle, the area of my base is going to be the area of this triangle, whose height is 10, whose base is 6. How do I find the area of a triangle, guys? We learned this last week. It's going to be 1/2 base times height, or base times height divided by 2. Okay, we're going to take that and we're going to get 30. That's my area. And then we're going to multiply that times my height of this prism, which is 5. So the volume is going to be 150 meters cubed. Okay, so you might be starting to see how we are taking that area of the base and all we're doing is multiplying it by height, keeping in mind we have to look for that base first. Now take a look at problem C. First identify what side, what parts of this shape is the base of the prism. You should be thinking this triangle up front. Okay? If you look straight across, boop, another triangle the exact same. So that is my base. So we need to find the area of this shape, and then we're going to multiply it by our height, which in this case is 10. So how are we going to find the area of this triangle? Well, the same formula. Okay? 1/2 base times height. What's the base of this triangle? Well, it's 8. What's the height? Oh, this might cause some issues. This might stop me in my tracks. But we have learned in previous lessons how to find the height of a triangle like this. Okay? Now you have 8, 8, and then over here we have another 8. showing me that this is an equilateral triangle. In section 8.2, we learned that if I cut an equilateral triangle in half, the height would be 8 root 3. That was section 8.2 with our special right triangles. We had our isosceles, and then we had our equilateral and cut in half. So if I have this triangle where the base is 8 and the height is 8 root 3, I can find my area, which would be 1/2 8 times 8 root 3. Now I'm going to go ahead and just tell you guys that we should go ahead and do this with decimals. So if you guys are thinking, like, I don't want to keep that root 3 in my answer, that is fine. Let's go ahead and turn that into a decimal. When I plug this into my calculator, I get around 55.4. Okay, so that's just the area of the base. How do I find the volume? Well, I'm just going to take that area, I'm going to multiply it by height, which is 10. So my answer ends up being about 554, and that'd be cubic inches. Okay, so we've done 3 different volumes. We've done one really easy volume of a rectangular prism, one that you guys are really familiar with, and we've done 2 different triangular prisms, one where we found the area of the base pretty easily, and one where we had to do some extra work to find that volume. So just keep in mind that we're not just reviewing volume from 8th grade. We are doing volume in a way that we are utilizing tricks and skills we have learned in the last couple chapters. That being said, let's go ahead and move on to question 2, which is what is the volume of this cylinder? Now, volume of a cylinder is going to have your same volume formula as prisms, because a cylinder is just a circular prism. So we just need to find the area of the base and times it by the height. Our height is 8, which is given here, and you guys should know, I shouldn't have to tell you this, that our base is going to be that circle, whether it's on the bottom or the top. So we need to find the area of that circle and then multiply it by our height, 8. How do I find area of a circle? Well, from the last week's lesson, we learned that was pi r squared, r meaning radius. So what is the radius of this cylinder? It is 3. So pi times 3 squared, which is 9 pi. And we're going to take that and multiply it by our height, which is 8. That's 72 pi. However, if you would like to turn this into decimals, if the question asks for decimals, what number do we use for pi? We use 3.14. So that's going to be 226.2 cubic centimeters. So either of those answers I'm good with. Keep an eye out for what is it asking for, and if it doesn't ask you for anything specific, then you can give it in whichever way you want. Here it didn't ask for decimals, it didn't ask for you to use pi, so use either method you feel comfortable with. All right, let's go ahead and move on to question 3. We got the next 3 problems are word problems. A lot of these problems do end up being word problems just because when it comes to area and perimeter and volume, a lot of that is things that we use in our day-to-day life. So we need to be able to use word problems to solve. So what is the volume in cubic feet of a square pyramid with base edges 40 and slant height 25? So we have a square pyramid. So a pyramid with a base of a square that comes to a central point. And it says that the base edges are 40. Now, if this is a square pyramid and the base edge is 40, then we know that all the sides are 40. Okay, so just keep that in mind. And then the slant height is 25. So what that means is that the height from the bottom to the top, this dotted line I just drew here, that is 25. So to find the volume of a pyramid, that formula, as I stated earlier, would be 1/3 of our area times our height. Now, how do I find the area of that bottom base? Well, it's a square, so I'm just going to do base times height, or length times width, which is 40 times 40, so that's 1600. But what is our height here? Remember, height is always from the very bottom straight up. We've always talked about height like that. But here, the only height I have is a slant height. That's not the same thing. So what you got to think about is, what is that height if the slant height is 25? Well, let's go ahead and redraw that over here. Okay, so here's the height we're trying to find. We know the slant is 25, and we know that the entire base edge of the pyramid is 40. So how do I figure out what this side is? Well, like we talked about with our area from the previous week, is that whenever I know what two sides of a triangle are and I want to try to find a third, I can use Pythagorean theorem to do that. So let's take a look at this triangle here. We have 25 as our hypotenuse, this is our x, and this would be half of 40, which is 20. So h squared plus 20 squared equals 25 squared. And you're going to go ahead and solve that for h. When you're done, you'll get 15. So my height is 15. So now I can go ahead and find my volume by doing 1/3 times 1600 times 15. Go ahead and multiply that in your calculator. You're going to get 8,000 cubic feet. Okay, now we're now on question 3. You guys should be getting used to the idea that these are going to be really big numbers. And you got to think about that. We're multiplying a lot of numbers, so we're going to have some big volumes here. All right, that was a pretty difficult one. So if you need help with that, please make sure you shoot me a message, and I'll explain it to you guys in detail. 2 more questions, guys. The covering on a TP rests on poles that come together like concurrent lines. The resulting structure approximates a cone. If the TP picture is 12 feet high with a base diameter of 14, what is the approximate volume? So we have a TP, which is they said it's like it approximates a cone, which makes sense. You got these poles that come together. They wrap the fabric around those poles. It ends up making this cone-like shape. They say that the TP is 12 feet high, and that the base diameter is 14 feet. What is the approximate volume? So just like we mentioned before, cones have the same type of volume that pyramids do, with it being the area of the base times your height, but it's 1/3 of that. Okay, so it's 1/3 of a cylinder essentially. So what we need to do first is we need to figure out what is our area and what is our height. So the base of this shape is going to be that circular bottom piece of the TP. The diameter of that TP is 14. Area of a circle is pi r squared. So what's my radius if the diameter is 14? You should get 7. Okay, so the radius is 7. 7 squared is 49. So we got 49 pi is my area here. What's my height? Now, unlike the last question, they just give you the height here, so we're just going to go ahead and use that 12. So 49 pi times 12 times 1/3, that's going to give us 196 pi as our volume there. Okay, as I've mentioned